Now, we want to take question one. He said a river is 120 meter wide and the water flows at 2.5 kilometer per hour. A ferryman who can score in still water at 3 kilometer per hour wishes to cross the river in a direction at right angle to the bank. A. C. Calculate the velocity in still water. B. The direction in which he must steer the boat. C. The time it takes to cross the river. Now, from the question, we have the wideness of the river. Wideness, which is what? 120 meter. That is the wideness of the river. Now, if the river is what? Is flowing this way. So, we are going to have what? Let's say if you want to go directly, this is the direction to flow or it will go. Now the river, they say it's flowing what? Water flows at what? So this is the direction of flow, 2.5 kilometer per hour. Then we have they said what? The ferryman can score in still water at 3 kilometer per hour. So that means this is the direction it will score. Why do I take direction? Because they say you calculate velocity in still water. So this is the direction. This is what? Flow of water. So velocity is still water. So this one is 3.0 kilometer per hour. This is direction at which what? The ferryman will steer the what? The head at an angle theta to the shore. This is alpha. So for us to find, they see what? Velocity is still water is now be equal to what? Which is square plus what? 2.5. Let me do it here. Equal to what? 2.5 plus 2.5 equal to what? 3.0 square. That means opposite adjacent square. Now what do we do now? We now make VS solve the formula, which is what? Square root from there to what? 3.0 square minus 2.5 square. What do we have? I want to have it as what? 1.66 kilometer per hour. Very clear. Now this is the velocity of what? At which it will score in what? In what? That the velocity is still water. Now they say what? The number two say B said what? The direction in which you must steer the boat. That is this direction, theta. And to get theta, tan theta can be solved by what? Using opposite over what? Adjacent here. Is 2.5 by 1.66. You can get it. You can also get it through sine equal to what? Opposite over what? Hypotenuse. So yeah, let's so that means theta will now be what? An inverse of what? 2 points. Just do it directly. 1.66. Yes. 56.44. Okay, 42. Okay. So that is just that. So that is direction to be steer the boat. Now you can also, this one is to the what? To the shoreline or to the shore, which is the same thing as this angle here. That means n. That is the angle just from theta. It can also be to the bank, which is this. So angle to the bank, that be 90 minus 56.42 to the bank. What do you have? That is 33 point what? 33.58. So that is it. So this is 33.58, which is same as this one. So now we have solved the question. Then the last one say time it takes to cross the river. The time can be calculated to cross the river. River equal to what? The river width divided by velocity in what? In still water. So if we want to find that, what is our velocity in still water? The width is already what? 120. If you convert to kilometer, divide by 1000. So that was 0.12 kilometer divided by what? The velocity is still water with 1.66 kilometer per hour. What do you have? 0.07 what? 2. You multiply what? This one is hours, I mean. So in minutes, that will work 4 point what? If I multiply by 60 minutes, that's 4.34 minutes. Yes. multiply by 60. So that is just that. We have gotten that the question. Now we go to number 2. Now number 2 say the speed of a boat in still water is 20 kilometer per hour. At what angle should it be heading in order to what? To travel directly across the river whose current has a speed of 12 kilometer per hour. To find the velocity. Now the velocity now we are looking for now, they said what? The boat, this is a river width. So let's say the width of the river they did not give us. River is flowing like this. Now we cross directly from A to B of the river, start taking this as a starting point, A, here's B. Then the what they said what? The velocity in what? The speed of the boat in still water is 20. Read that one first. They said what? The current has a speed of 12 kilometer. Current direction of the river is 12 kilometer per hour speed. So that is to cross the river directly, you pass through this direction. So velocity of the boat or the actual velocity, they give us what? They said what? The speed of the boat in still water, that means speed of the boat, the actual speed is this one, which is what? This one is going like this. This what? Like then this one. Now this one is giving us what? 20 kilometer per hour. So that's what? We should calculate the what? The velocity with which we cross what? What angle should it be heading in order to travel directly across the river? That is this angle. This angle they ask us. But we can see the velocity to cross directly. That the VS. This is the angle in which must be headed to cross, to move to the opposite bank. So that means to solve it, we are going to have VS. We have to find VS now. It's equal to square root of what? 20 square plus 20 square plus minus 12 square. How do we get that? No, VS square plus 12 square is equal to what? 20 square, like my Pythagoras theorem. So VS now the square equal to what? 20 square minus what? 12 square now. Abi? And 400 minus 144 equal to VS square. So if you want to find square root, now the square root of what? 400 minus 144. What do you have? 16. Abi? 16 kilometer per hour. But that is not what they ask. They ask on which direction must it be headed. So that means tan theta if you want to use this one, but you can use sine if you want to use what? Opposite over what? Hypotenuse. Where this one is opposite and here is what? Hypotenuse. So you can use what? 12 to find this angle over 20 opposite to hypotenuse. So theta will now be sine inverse of what? 12 over 20. What do you have? 36.87. Excellent. It's about 36.9. Abi? Degree approximately. So this one is 36.9. That is direction to the shore. This is what? To the shoreline. The shore. Why? To find the angle to the bank is what? What? The angle to what? To the bank. Now, what do we have? We subtract 90 minus what? 36.9. What do you have? 53.1. Why the angle to the what? To the opposite what? Opposite bank. Opposite bank. For you to find the angle to the opposite bank, what you are going to do is just to add what? This angle to the shore, add 90 to it. You are going to have what? 126.9 thereabout. Abi? Yes. If you find tan of what? 126.9, it will give you what? Negative of what? Of what we are going to have 30, a tan of what? 53.1. If you do it, you see. It shows that negative indicates opposite bank. So that is just that. So we have solved the direction to the shoreline, to the bank, and we have also calculated the answer of velocity in still water before. Because they say find the velocity, that velocity that you used to cross or to be headed. Number 3 question, he said what? A boat crossed a river 1.5 wide. That means this is the width of the river. It is 1.5 kilometer wide. Mm-hmm. In what? In what? How many minutes? 15 minutes. That is the time. Okay. So that means for us to find the velocity of the boat relative to the what? To the river, because the river flows this way, this direction. That is river flow. So that means we are going to have what? The width or the wideness divided by what? The time. So that means velocity is still water now. So that will now give us what? 1.5 kilometer divided by what? 15. If you convert 15 minutes to hours, you are going to divide by what? 60 to convert to hour. So what do we have? 0.25 what? Meter kilometer per hour. Abi? 0.25. Then having gotten that, no, that should be what? Huh? That means the down one, which is what? 0.25 hour. Abi? So if now divide it, what you have? 6 what? Kilometer per hour. So we have gotten what? The velocity we have to travel directly the river, which is what? 6 kilometer per hour. Mm-hmm. And the what? It will steer it at which angle to go to this or what? Which is the actual direction, the actual speed. To cross the river directly, this is which velocity is that what? Of the boat related to the what? To the river. Why the velocity of the boat related to shore? Yes? What they say? They say what? If the river flows, this is the current direction or the river flow direction is what? At 2 kilometer per hour. Mm-hmm. Calculate the velocity of the boat. This is the actual velocity of the boat. The velocity of boat now relative to the shore. So that means velocity of the boat b square equal to what? VBR square plus what? Velocity of the river square relative to the shore. So in that case, what we have, I want to have it as what? It implies that therefore VBX equal to what? Square root of what? VBR square plus VRS square. What do we have? I want to have about 6 kilometer per hour. Okay, 6 rather. Let me just 2 square root of everything. That will give us 36 plus 4 is square root of 40. And what is the value? 6 point what? Kilometer per hour. You haven't gotten that, we have solved what. But if they ask you for angle to the what? To the shore, you can solve it just for tan inverse of what? We are using this, where is 2/6, abi? You get your answer. What is tan inverse of 2/6 to angle to the shore? 18.43 degree. The angle to the bank will now be what? 90 minus what? 18.43. Yes? 57, abi? Excellent. So, in fact, the angle to the bank can be written here, can be here too, which somebody can interpret as what? Is what? 71.57 what? Degree what? North. Or 71.57 north of east. You can present it like that. We don't be carried away for direction. But we have solved the question. Now we go to number 4. Now we move to number 4. It said a swimmer swim north across what? A swimmer swim north. Swim north. That means if I have what? This is north. This is swimming direction north. With what angle? Swim at what? Swim north across a river flow of 0.2 what? That means the river flow is what? Sorry, across a river flow that flow from west to east. Sorry for that. This west to east. That means direction, no? With which velocity? 0.2 meter per second. The swimmer swim what? North across the river flow at what? 0.2 meter per second from west to east. If the swimmer what is 0.15 meter per second relative to the what? Swimmer velocity is 0.15 meter per second relative to the still water. What is the swimmer velocity relative to the river bank? So now This is what? Swimmer velocity, eh? Relative to what? To the still water. This is what? Vs, and it is giving us as what? 0.15 meter per second. What is the velocity of swimmer relative to the what? River bank or to the shore? This is it. Velocity, look at it there. This one is one swimming north. This one from east to west, or from west to what? To east. So we are looking for V what? Velocity of the what? Of the swimmer related to the river. So that means Vxr equal to what? This is the bank of the river. This is the wideness of the what? The width. They are asking. So this one now is the direction in which it will steer the boat to cross the river, which this direction. So this one now, v square equal to what? 0.15 square rectangular 0.20 square. So what do you have? That would have SR equal to what? Square root of what? 0.15 square plus what? What do you have now at the final? 0.25 meter per second. Now they said what? Which direction? If they ask us which direction, they have answered the question already. This is the question, but the answer of direction, this direction can also be likely to be this. I told you this one can be T alpha, which is this one, because here is what? Is equal to alpha, and vertically opposite angle are equal. Here is theta. Here is also what? Theta. Alternate angle are equal. Then if here is equal to this place, alternate angle, then here will be equal to this place, vertically opposite angle. So if I want to solve for theta, tan theta can be equal to what? 0.2 divided by 0.5 quickly, which is theta equal to tan inverse. People tan inverse of that value. What do you have? So tan inverse of 0.2 divided by what? So we are going to have it as what? 53.13. That is it. So that means this one is 53.13. That means to the shore. To the shore. What about what? To the bank? It will not be what? Alpha. This theta. It will not be 90 minus theta. What do you have? Angle to the shore. 87, abi, approximately what? Let's say 37 degree, abi, to the what? To the bank. Now, if they present it like this, they still present it like this. We have seen questions where they will present the answer like this. Now the what? East. 37 degree what? 37 degree what? North, or 37 degree what? North of east. So that would be your answer for the what? To the bank. So thank you. Number 5, he said a boy swim at what? 6 meter per second across a river. So if the boy swim what? 6 meter per second across a river in which the water is flowing at 4 meter per second. If the direction of his swimming is at right angle to the bank of the river, find the velocity of the swimmer relative to the what? To the river bank. Now what I want to do now is what? We have the wideness of the river, which is what? The width from here. Now if is what? The river is flowing toward eastward like this. Now if you have to cross directly, is like this, which is what? Now in the question they said what? The boy swim what? Across a river in which what is the river flow? Flowing at what? The river is flowing at 4 meter per second. If the direction of the swimming is at right angle to the bank, so at right angle to the bank, this is the river bank. The river bank. Now, so that is to say that the swimmer is swimming what? 6 meter per second, swimming at right angle to the bank. So what we need what? The velocity of the swimmer. This one is velocity of swimmer, velocity of what? Of what? River water flow. So or the river, as the case may be. So this one is velocity of what? Swimmer related to water, to the river rather. So to the river bank. velocity of swimmer related to the river bank. So that will now give us what? So that will give us x vxr is equal to what? 4 square, like 4 square plus what? 6 square. So what do you have? Vs equal to what? 16 plus what? 36. So Vs equal to square root of what? 16 plus 36 will give us what? Everything is 7.21 meter what? Per second. Now, but if they ask us for direction, maybe sometimes they can ask us direction to the shoreline, you can solve it, you can do that one by yourself. Then direction to the river bank, this is shore. And get if they ask for time, time is what? Width given to you divided by what? 6 and so forth and so on. Let's move to number 6. Now it said a river has a current with a velocity of 1 meter. That means this is the river width. This is the river width. Now this is the river width, the width of the river. Now if you have to cross directly, this is the direction you will cross. They say the river has a what? A current with velocity of what? 1 meter per second. East, okay, east. They give us east, 1 meter per second, east. So this is what? East, north, south, west. Eastward is that way. A boat whose speed in still water is 5 meter per second is directed across 5 meter per second, directed south across the what? 100 meter what? Wide river. That means it's 100 meter. So it's directed 5 meter across what? The 100 meter wide. That means across mean that what? That means is what? Like this. So they said a boat whose speed is still water. This is velocity of the what? Boat is still water. Is directed across the river. Now they say what? How long does it take the boat to reach the opposite bank? How long? They are looking for time. Time is what? We need to get our what? Our what do you call it? Velocity first. But if you check the question very well, that they gave us, they say what? A boat whose we draw a wrong diagram. Now this one is east. Sorry for that. They say a boat whose speed is in still water is 5 meter is directed south. So south is what? It's downward. So if I want to draw it now, let me see. This is 5 meter per second downward. South, that is south direction. So if this one is south direction, this one is east, which is that way. Therefore, I can redraw the diagram like this. Look at the board. South, which is, let me redraw the diagram this way at the board. This 1 meter per second. Sorry for that. Then south is what? Downward, which is this one, 5 meter per second. This 1 meter per second. Then this one will now go what? So that the arrow, that means it's starting from here. Starting is A to B is if it's to move directly. From A to B. Now, in this case now, this is the direction of what? Of the shore, angle to the shore. Then which is also alternate to what? To this angle theta. Is be getting it. So to reduce the complexity of it, let me remove this. Let me remove this. Now, so you see now. So it's moving what? It says what? A river has a current with a velocity of 1 meter per second east. So this is east, correct? Then now say what? A boat whose speed in still water is 5 meter per second is directed south. That's south here, downward, following the direction I place. Then if you check the arrow, the two of them must be going in the same direction. That's why I try to get the orientation right. If the two of them are not moving in the same direction, and this one, the resultant or magnitude velocity will be against the two directions. So that means that the starting, this is the upstream and this is the downstream. So this is what the opposite bank that we are talking about. He landed at the opposite bank with this angle theta. The other here is alternate to this one. So now, what did they say we should find now? How long does don't forget the wideness of the river was given to us. They said across the 100-meter wide river. So the width is 100 meter. Then how do we find the time? The time to cross the river quickly, to cross the river, that means how long, that is question A. How long does it take the boat to reach the opposite bank or opposite shore? That means time to cross the what? The river. The time to cross the river is equal to what? The width, wideness over the velocity in still water. So if the what, that is what? The velocity in what? The velocity in still water, which is given as, so what is the value? We are giving 100 meter divided by what the velocity is still water, 5 meter per second. So that will now give us 20 seconds. Very clear. That means to move from here to this place. And don't forget, it will be now be steering like this now. It will be steering this way now. That is steering direction. So in that case, now it will be steering that way. Now, in this case, coming from that side, so the arrow must be here. It's coming down. So now the next one is what? How far will the what? The boat land? How far? How far will the boat land what? How far downstream will the boat what? Land? How far? Now, how far is talking about what? Distance. That means from the upstream, is from here to the downstream. So how far is talking about distance. So don't forget the time to cross the river is equal to what? Distance of downstream, which you are looking for. Downstream divided by what? The current velocity. So that is the formula we are going to use. We are looking for distance of downstream. So if we know that, now we cannot cross multiply to make this one somewhere. So distance of downstream, distance of downstream is equals to what? The time multiplied by current. What is time? 20 seconds times what is the current movement? 1 meter per second. So that will give us what? 20 meter. Exactly. So that is what? How far the boat will land downstream. What is the velocity of the boat related to the shore? This is the velocity of the boat related to the shore. Because the velocity of the boat related to the shore is equal to velocity of what? River related to the what? Shore plus velocity of the boat related to the river. This is velocity of the boat related to the river, which is going south. This is velocity of river related to the shore. A river velocity is boat velocity to cross the river directly. Now, if you want to now solve it using what? That would have VB square plus BR square plus Pythagoras theorem. So quickly, let's go. VBS, which is question C. Don't forget this line is B. C now is what? Square root of what from here? VBR square or VB what? RS plus, yes, plus what again? VBR square. Where now? Let's put the parameter there. What is the parameter for? That is this one. VBR square is 1 square. Yes, SLM. 5 square. What do you have now? 5.099. You can say VBS is equal to 5.1 approximately. Abi? Exactly. So that we have solved for A, we have solved for B, we have solved for C. So we have solved for how long does it take to the boat to reach the opposite bank. We have solved for how far downstream will the boat land. We have solved for what is the velocity of the boat related to the shore. Now, the last question for this section is that it said if the person on the boat in the western 6 so above want to travel directly across the river, what angle must it be directed? Okay, let me have the sketch that we had before. Those of you that are following, so just subscribe if you are enjoying the video, please, to encourage us. So this is what 5 meters per second. So initially, I'm repeating the diagram before. So this is what we had. I think it's different. I don't think it's different. So this is what, according to our direction, is north, east. This one was traveling what? Eastward from southward. Okay, that was the direction we had. And there is what? This is the bank, opposite bank, where it's traveling. The river bank. Traveling here. I told you the arrow must be following each other. Must be continuous. Then this one must be against it. Now, but they said what? If the person on the boat is what? In the question 6, which is this one, question 6, but want to travel directly. That means you want to move like this now. You want to travel directly now. You want to move directly from A to B. That means you have to give this one to the what? That means the 5 meters per second will now be the actual speed. Why we now solve for this? This is now the velocity of the swimmer of the boat itself directly. This one is the velocity of river. Now, how do we get it? Now, the direction to which it will come is what will be determined by what? By this direction rather. This one until it will land at the opposite bank with this direction. So we can solve that direction. And we can also know that this one is the alpha, which angle to the bank is an opposite bank now. Because it's coming from here. That's why I call it opposite what? Bank. Now, how do we first of all solve? Now, let's say what direction must it be directed? What angle must it be directed? So, we are going to use what? Tan theta equal to what? No, not tan theta. Let's use sin theta equal to what? Opposite over what? Hypotenuse. So, what we have theta will now be what? Sine inverse of what? Class 1/5. That means 11.54. Now, if you check that last one, you really solve the direction. You did not solve the direction. So, you can always solve the direction of that last one using the idea that we have given you before. The same way I solved the direction. You know that last one, the 5 meter was what? Number 6. It was here. So, when you want to solve now, you use what? Tan to solve it, which is 1/5 tan inverse of to get theta. But now, this one is sine because we have changed the what? The velocity of that you used to travel directly will be replaced with the actual velocity. Velocity of the boat related to the what? River. We have changed it to what? To this part, which is the actual speed. So that's why we're here. This one now be what? Approximately what? 12. That is the direction. That is question A. B says what? With what speed will the boat cross the river? That is what? This speed. B. So VB is equal to what? Don't forget this on the adjacent side of the angle. So we can write it as what? 5 square equal to what? VB square plus what? VR is VR square. So what do we have? V5 square equal to what? VB square plus VR is what? So how do you get VR? VB rather? 5 square minus 1 square. Now I can make a separate formula. So VB will now be a square root of what? Yes, what do you have?
That's 4.8.
Which approximately what? 4 point what? So that is 4.9. This velocity to cross the river directly. Move directly. That means straight down. Which is the velocity that is perpendicular to the river bank. The bank. Or perpendicular to the current direction. This is current direction. Okay. What does it see? It says how long will it take the boat to reach the opposite bank? That means time. We have solved using time ever since we started this section. So velocity of what? Of velocity is still water. Will now be equal to what? Which is this velocity, or velocity which you travel directly. So what we have now, we have what the wideness of the, if you check the wideness of that former question was what? Number 6 was 100 meter. Abi? That is the wideness now, 100 meter. So in that case, we use what? 100 again. But this time around, it has changed because we are now using what? 4.9 as a velocity still water meter per second. Yes?
Thank you for
20.41 seconds. So this is the time it will take to what, to cross the river from point A, which is to destination of opposite bank, point B. So you can solve for the angle. This is angle to the shore. Don't forget angle to the shore line. You can always solve angle to the bank by removing this one from 90. I think we have done several of them in this class. So very clear. Just know that if you want to travel directly, you have to change what, that 5 meter to the actual speed, because that is the velocity we will now use to travel directly to the small bank. But that is to travel to the what, to the opposite bank. But the one that you use to cross directly, which is the one perpendicular to the current velocity or perpendicular to the opposite bank, is what, 4.9 meter per second. So I believe we have make the video very very clear, combined with what we have done before with the analysis. So if you have watched the analysis and watch this particular question, I believe you know have problem with relative velocity. Thank you very much for watching. If you know you enjoyed the video, please just like and subscribe to encourage us, and also tell people about the channel. God bless you. Have a wonderful day. Thank you.